Hello everyone, myself Devotha Naik. So today we will discuss about electric potential energy. So what do you mean by electric potential energy? Suppose we are taking a test charge from infinite to a given point. Okay, any charge, let's say Q1 charge. So if I will take that Q1 charge from infinite to this point, I don't have to do any work because no other charge is there, no electric force is there, right? So I don't have to do any type of work. So we have to bring this test charge from infinite to given point, this point, no work done. Okay, so potential energy is also zero. Let's say another test charge Q0 is at infinite. So I want to take this charge from infinite to a given point. Let's say this distance is r and this distance is r or infinite. Okay, x, you can say in x distance that test charge was there. So now situation scenario is different. Here if I want to take this charge from infinite to this point, this electric force will be there on this Q0 charge. Electric force will be there in this direction, Fe. So if I want to take this Q0 charge to in this side towards left, okay, so I'd have to do a work, external work done we have to do. Okay, right? So here you can see external work done is there and we want to take that charge so slowly. Here this is very important. We have to do that work and that work done will be very slow. Slowly we want to take that to distance r. Like in a bow and arrow, if you are getting that string slowly, some amount of potential energy will be absorbed in the string. Like that, if you want to get that test charge from infinite to this point, some amount of potential energy will be stored. And how much potential energy will be stored? That how work done, how much work is done, that is the potential energy stored. We will see that. Okay, so this is the basic idea. So if you will see, this is some electric field is there. Okay, so due to that electric field, I have to do some external work done, right? Because electric force is in this direction, electric force away, so I have to give some external electric force. Okay, so this is the external force, and remember external force is equal to magnitude wise. External force is going to be equal, that's why small, the displacement will be very small. Okay, and this external electric force will be variable, as you can see. Why? Because when test charge was at this point, right, at this point, so distance is high, force will be less, but when it is coming closer, distance is small, force will be high, right? So this is variable. So and that the process is so slow, kinetic energy change will be zero. So this is some basic fundamental things related to this. And as we know, work done is equal to negative potential energy. This is the thing we know that from work energy theorem. Like here if you will see, total work done is equal to change in kinetic energy. This is also a work. This is also from work energy theory also. Total work done, you can see some electric work done is there on this direction, and to counter that external work done is there. So external work done plus total work done is equal to electrostatic, and that change in kinetic energy is going to be zero because we are pulling that string so slow, like that we are taking that test charge very slowly. Okay. And external plus, and here electrostatic force is a conservative force, and conservative forces, here also you can write work done by conservative force. Conservative force is equal to change in potential energy. Okay, conservative, because electrostatic force is a conservative force, so del U equal to 0, external is equal to minus of change in potential energy, or you can write that directly also. Okay, so how much external work we need? Here what we got that the amount of potential energy stored in this system will be how much work is done to take that test charge to this point. Okay, so we got that. So the potential energy will be work done. So we need to find out that work done. That work done will be change in potential energy. So work done will be F. Here let's say this test charge was at a distance x, that x is varying from r to infinite. Okay, so let's say this is the distance x, so dx, small dx's will be there, dx, and dx are in this direction. We are pulling the charge in this direction, and external force is in this direction, right? So both same direction, so angle will be 0 degree. F dx cos 0 infinite to r. Electric external force will be electric force equal to k q1 q0 by x square, this distance. So k q1 q0 by x square dx integration infinite to r x to the power minus 2. So this will be minus k q1 q0 by x r infinite. Okay, and here you can see that this negative sign is f external is equal to minus k q1 q0 1 by r, k q1 q0 by r. This minus is outside. Okay, and upper limit minus lower limit, so this is going to be 0. So k q1 q0 by r. So change in potential energy, equal to minus of work done, that is equal to minus plus. So k q1 q0 by r. So this is the potential energy stored when we are taking that test charge from infinite to a given point. But before that, when we are taking that q1 charge, that mother charge or that source charge from infinite to a point, no other charges were there, so work done in that case is 0, so potential energy will be 0. But the second charge, test charge q0, when you are bringing that, then you can see कि वहाँ पे पोटेंशियल एनर्जी स्टोर होना स्टार्ट किया. ओके, अगर कोई एक चार्ज रहेगा पहले से सोर्स चार्ज, तब वो दूसरे को इन्फ्लुएंस कर सकता है. जैसे कि मान लेते हैं कि हमारे लाइन में तुमने मार्क किया होगा, तुम्हारे लाइन में जब कोई डॉग नहीं रहता, ठीक है, तो कोई एक नया डॉग दूसरे लाइन से तुम्हारे लाइन में आ जाता है और आराम से रहता है, तो कोई झगड़ा वगड़ा नहीं रहता, वो आराम से फ्रीली रहता है. तो वहाँ पे वो डॉग को वर्क डन कितना करना पड़ा? 0. ठीक है, तो पोटेंशियल एनर्जी डॉग का तब 0 है। लेकिन तुमने मार्क किया होगा जब कोई दूसरा डॉग, सेकेंड डॉग जब दूसरे लाइन से आता है तो वहाँ पे बहुत झगड़ा होता है, ठीक है। तो वहाँ पे पहला वाला डॉग दूसरे वाले डॉग को इन्फ्लुएंस करने के लिए ट्राई करता है, तो वहाँ पे KQ1 Q2 बाई आर की तरह काम करता है पोटेंशियल KQ1 Q2 बाई आर। जब थर्ड वाला डॉग आएगा तो कुछ टाइम के बाद फर्स्ट और सेकंड डॉग के बीच में सेटलमेंट हो जाएगा, तो लेकिन जब थर्ड डॉग आएगा तो फर्स्ट डॉग भी इन्फ्लुएंस करेगा, सेकंड डॉग भी थर्ड डॉग के साथ इन्फ्लुएंस करेगा, तो उस टाइप का वो रहता है, ठीक है। तो सिंप्लिसिटी के लिए इलेक्ट्रिक पोटेंशियल एनर्जी, जब कोई एक चार्ज रहेगा पहले से, दूसरा चार्ज या तीसरा चार्ज या फोर्थ चार्ज जब आने के लिए कोशिश करेंगे तो वर्क डन टू टेक दैट चार्ज, वही हो जाएगा पोटेंशियल एनर्जी। तो पोटेंशियल एनर्जी का फॉर्मूला कितना है, KQ1 Q0 बाई और Q1 Q2 बाई आर, और इलेक्ट्रिक फोर्स का KQ1 Q2 बाई आर स्क्वायर। इलेक्ट्रिक पोटेंशियल का कितना है, KQ यहाँ पे देख लो, इलेक्ट्रिक पोटेंशियल का कितना है, डेल V, ये डेल U है, डेल V इज इक्वल टू KQ1 बाई आर, ठीक है। और इलेक्ट्रिक फील्ड का कितना है, KQ1 बाई आर स्क्वायर। तो यहाँ पे इलेक्ट्रिक पोटेंशियल डिफरेंस और इलेक्ट्रिक पोटेंशियल एनर्जी के बीच में तुम देख सकते हो, ऐसे हम देख सकते हैं, ठीक है, कि तुम अगर जा रहे हो शाहरुख खान का कॉन्सर्ट को देखने के लिए, तो वहाँ पे क्या करना पड़ रहा है, you have to pay some amount to see that concert, right? So that is electric potential difference per head, जो एनर्जी चाहिए, the work done to take that charge from infinite to a given point, वो per head जो होता है, यहाँ पे देखो एक Q नहीं है, KQ1 बाई आर, सो दैट इज पर हेड कितना खर्चा करना पड़ा। लेकिन तुम अगर दोस्त लोगों को लेके जाओगे तो इन दैट केस क्या हो जाएगा, 5 जन जा रहे हैं तो इंटू 5 हो जाएगा, चार्ज का वैल्यू एक्स्ट्रा ऐड होने के लिए चाहिए। तो पोटेंशियल एनर्जी क्या है, ठीक है, ग्रुप ऑफ दोस्त तुम जा रहे हो, इस टाइप का तुम याद रख सकते हो। और इलेक्ट्रिक पोटेंशियल डिफरेंस क्या है, अकेले जा रहे हो, तो वहाँ पे जो एनर्जी का डिफरेंस है वही है इलेक्ट्रिक पोटेंशियल डिफरेंस पर चार्ज, इलेक्ट्रिक पोटेंशियल एनर्जी ग्रुप ऑफ चार्जेस। वही वाला कॉन्सेप्ट यहाँ पे भी हम लगाएंगे इन द नेक्स्ट न्यूमेरिकल। सपोज मान लेते हैं कि एक सिस्टम ऑफ चार्ज है एक ट्रायंगल में, ठीक है, एक इक्विलेटरल ट्रायंगल में एक सिस्टम ऑफ चार्ज है Q1 Q2 Q3, और उनके बीच में डिस्टेंसेस है R1 R3 R2। फाइंड द नेट पोटेंशियल एनर्जी ऑफ द सिस्टम, ठीक है, फाइंड द पोटेंशियल एनर्जी ऑफ द सिस्टम। तो कैसे निकालेंगे इसको तुम यहाँ पे इसको कैसे निकाल सकते हो, हाउ टू फाइंड आउट। सो लेट्स से I am taking that Q1 charge from infinite to a given point, so no work done will be there, so W1 equal to 0। when दूसरा एक डॉग रो लाइन में आएगा, so in that case when Q2 charge will be there, so this is going to influence this Q2 charge, Q1 is going to be influenced, okay। so W2 work done will be कितना हो जाएगा ठीक है। तो के पोटेंशियल एनर्जी, ठीक है, दैट भी लिख सकते हैं कि पोटेंशियल एनर्जी कितना हो जाएगा, या फिर वर्क डन तुम लिख सकते हो, कोई प्रॉब्लम नहीं। तो यहाँ पे जो वर्क डन हो जाएगा के Q1 Q2 बाई R1, और जब Q3 चार्ज को लेके आएंगे तो क्या हो जाएगा के, ठीक है, यहाँ पे this Q3 charge is going to influence this charge and also this charge, so K Q1 Q3 by R3 plus K Q2 Q3 by R2, so this is the total work done to maintain this system। so if we will add them, so potential energy will be W1, total potential energy will be W1 W2 W3, okay। so likewise you can remember all these things, and another thing is there, if you want to know how many terms are going to come, like W1, W2, W3, if 4 charge system is there, how to know that how many terms of work done will be there? Okay, so number of terms will be in this formula n into n minus 1 by 2. So here let's say 3 charges are there, so terms कितना आने वाला है, 3 into 2 by 2, so 3 terms will be there as you can see. Okay, if 4 charges is there, so terms कितना जाएगा, how many terms will be there, 3 into 4 by 2, so 6 terms will be there. So you can remember this formula also, and you can make a homework. 4 charges system is there, and you can find the net potential energy of the system. We have to find that. So first we have to take that Q1 charge to the here, then AA square, Q2 charge here, so this work done, Q3 charge here, so this work done, Q4 charge is there, this total work done, you have to add them up. Okay. Let's say 3 charges are there, minus Q, Q and minus Q, A. Now what we have to find out, find the relation between or ratio between Q and Q such that net potential energy of the system is 0. Can you do that? Okay, can you do that? So simple, total potential energy to make this system equal to 0. So we will find that. If I am taking this minus Q charge from infinite to this point, so work done will be 0. Okay, if I am taking this Q charge here a distance, so work done will be K Q1 Q2 by A. When I am taking that minus Q charge, work done will be this first dog will influence and second dog also will influence, right? Here group of friends, you are coming, group of friends in SRK concert, right? So per head into how many other friends are there, so likewise you have to pay. So likewise, so net potential energy you can find by adding them up. So if minus Q is there, so influence minus Q, so K minus Q, Q1 Q2 by 2A, plus this influence will be there, K Q minus Q by A. Okay, so total potential energy will be, add them up, minus K Q by A, minus plus K Q square by 2A minus K Q by A. Okay, so potential energy is 0. So what do we got? K Q by A Q plus Q by 2 minus, okay, and KQ by A to minus Q, so 0, minus 2Q plus 4, so Q by Q equal to 1 by 4. Likewise you can solve other questions. Thank you very much.